Today, we like to continue with the square black matrix. The square black matrix, it is a black matrix. A black matrix A or M is said to be a square black matrix. If one only, first one, the matrix should be square matrix. The matrix itself is a square matrix. And its blocks form a square matrix. Right? That means number of horizontal lines is equals to number of vertical lines. Third one, diagonal blocks should be square. So this is a definition. A matrix which satisfies a black matrix which satisfies three properties is called a square black matrix. Example, suppose you take this. It's 1, 2, 3, 4, 5, 1, 1, 1, 1, 1, and you take anything, right? 6, 7, 5. Again, you can get 5, 5, 5, 5, 5, and 1, 3, 5, 7, 9. You take this matrix. Suppose your black matrix is given like this. Right? The matrix itself is a square matrix. Why? Because how many rows? 5 rows, 5 columns. It's a square matrix, okay. Satisfy the first condition. Okay. What is second one? Black form square matrix. What is a black matrix here? This is like a A1. This is A2. This one is A2. This is A3. Next, this is A4, A5, A6, A7, A8, A9. This is A1. This is A2. This is A3. This is A4. This is A5. This is A6. This is A7. This is A8. A9. Right? Therefore, it is a 3 by 3 matrix. Therefore, it is also square matrix. So satisfy the second condition. What is third one? Third one, diagonal blocks should be square matrix. So what is the diagonal matrix? What are the diagonal blocks? So this we are call it as a diagonal blocks. This diagonal line is called as a diagonal blocks. A1 is a square matrix. Why? Because A1 is nothing but 1, 2, 1, 1. It's a 2 by 2 matrix. Therefore, it is a square block, no doubt. 7, 5. But what about A5? A5 is nothing but 7, 5. It is a diagonal. It's a diagonal block, but which is not square. Not square. Square matrix. So there exists at least one diagonal block which is not a square matrix. Hence, it is not square block matrix. Which is not. Therefore, A is not square block matrix. Suppose, is it clear? All of you? Hello? The matrix should be itself is a square matrix, and its blocks must be blocks form a square matrix, and as well as diagonal blanks should be square matrix. Diagonal blanks should be square matrices. Is it clear, all of you? Okay, so therefore, if I take another example, same example, but if you take the different partition, suppose 1, 2, 3, 4, 5, 1, 1, 1, 1, 9, 8, 7, 6, 5. Suppose you take 5, 5, 5, 5, 5, right? 1, 3, 5, 1, 3, 5, 7, 9. Suppose my blocks are like looking like this. Suppose vertical lines, how many vertical lines? 2. Unit horizontal lines 2. First, it is a square matrix because it's a 5 by 5 matrix. First condition satisfied. What is second one? What is second one? Blocks form a square matrix. What is a blocks? Blocks form a square matrix. It's itself is same as saying that number of horizontal lines is equals to number of vertical lines. Number of horizontal lines, number of vertical lines 2, number of horizontal lines also 2. Therefore, satisfying the second condition. Right? Number of vertical lines is equals to number of horizontal lines. Right? So satisfying second condition. Next, what are the diagonal blocks? This is actually what this is A1, A2, A3, A4, A5, A6, A7, A8, A9. My diagonal blocks are nothing but this one, A1, A2, this one. What is A1? A1 is a square matrix. This diagonal matrix, this diagonal block itself is a square matrix. Okay. Next, what is A5? 7. It is also square matrix. It is a 1 by matrix. It's a square matrix. What is A9? A9 is 5, 5, 7, 9. It is also square matrix. Therefore, all diagonal blocks are square matrices. Therefore, it is a square block matrix. Therefore, given matrix A is a square block matrix. A square block matrix. Is it clear, all of you? Next is, suppose we take another definition, black diagonal matrix. These are very, very, very important black matrices. So black diagonal matrices. Black diagonal matrix means same definition. Something like same. So a square black matrix is said to be black diagonal. Matrix if only all the non-diagonal blocks, all the non-diagonal blocks are zero matrices. So same it is looking like a diagonal matrix. What is diagonal matrix? All non-diagonal matrix should be zero. Right here, non-diagonal blocks should be zero matrices. Suppose you take this, A is equals to 1, 0, 0, 0, 0, 2, 0, 0, 3. My block is, yeah, question is it a black diagonal matrix? The answer, no. It is a square matrix, okay, but blocks, what is the second condition? Blocks form square matrix. See how many horizontal lines? See how many horizontal lines? One. One many vertical lines? One. Therefore, satisfying second condition. What is the third condition? Diagonal blocks, what is my A? A is nothing but A1, A2, A3, A4. It is nothing but diagonal. So A1 is nothing but 1, 0. Diagonal element, diagonal matrix, diagonal black is not a square matrix, right? Therefore, it fails to satisfy the third property. Therefore, it is not a black diagonal matrix. It is not a black diagonal matrix, right? Suppose same example, if you take the same example, but the partition is different. 0, 0, 2, 0, 0, 3, right? Suppose I partition the matrix like this. Now, it is nothing but what? A1, A2, A3, A4, right? What is A1? A1 is 1 matrix, 1 by 1 matrix. A2 is nothing but what? 0, 0. A3 is nothing but what? 0, 0. A4 is nothing but what? Square matrix, 0, 2, 0, 3. Therefore, what you observe is it is a square matrix, okay? A square matrix, right? So it is a given matrix is a square matrix. Given matrix is a square matrix, and blocks form square matrix, satisfying the second condition. And that actually diagonal blocks, these are diagonal. A1, A4 are the diagonal blocks. A1, A4 are square matrices. Therefore, A is a square black matrix. A is a square black matrix. Question is it a diagonal black matrix? It's a black diagonal matrix. The answer yes, because off diagonal elements. What are off diagonal elements? These are nothing but off diagonal elements. This one and this one, they are off diagonal blacks. Once they are off diagonal blacks, they should be zero matrices. So A2 is a zero matrix, A3 also zero matrix. Therefore, it is a black diagonal matrix. Therefore, A is black diagonal matrix. Is it clear, all of you? Hello, put it in chat box. Is it clear?
Yes, sir.
Yes. Next is upper triangular black matrix. Black upper triangular matrix. Same definition, looking like a matrix, upper triangular matrix. Right? What is it? A square black matrix. Is said to be black upper triangular matrix. What is the definition? All the blocks below the diagonal, right, are zero matrices. Right? Example. Same. You can take this example. Suppose you can take 1, 0, 0, 0, 0, 2, 0, 0, 3. This is my matrix. What are my partitions? My partitions are looking like this. Yeah. Is it a square black matrix? Yes, because the matrix itself is a square matrix, and the number of horizontal lines is equal to number of vertical lines, and blocks, diagonal blocks are square matrices. This is 1 by 1 matrix. This is 2 by 2 matrix. Therefore, diagonal blocks are square matrices. Therefore, it is a square black matrix. Therefore, it is a square black matrix. First one is over. Now my question is it a black upper triangular matrix? Yes, because all the, see, this is looking like what? This is A1, A2, A3, A4. This is a black matrix. This is 2 by 2 black matrix. Right? What are my diagonal blocks? These are my diagonal blocks. Right? So what is A1? A1 is nothing but 1. A2 is nothing but what? 0, 0. A3 is nothing but what? 0, 0. A4 is nothing but what? 0, 2, 0, 3. Therefore, all the diagonal below, all the blocks which are below the diagonal are 0. You know, A3 is 0, right? A3 is 0, right? This is my 0 matrix. A3 is 0 matrix because below the diagonal is a 0 matrix. Therefore, it is a black upper triangular matrix. A is a black upper triangular matrix. Right. Next is, what is lower black lower triangular matrix? Black lower triangular matrix. A square black matrix is said to be black lower triangular matrix if and only if the same definition, looking like a lower triangular matrix. All the blacks above the diagonal are 0 matrices. Right? Suppose you take the same example, 1 0 0, right? Like 0 0 2, 0 0 3. Right? What are my partitions? These are my partitions. Right? You know, clearly it is a square black matrix. We have seen is A1, A2, A3, A4. So look at the diagonal. So above diagonal, what is above diagonal here? A2. A2 is above diagonal matrix. You know, it is a 0 matrix. Therefore, satisfies all conditions. Therefore, A is a black lower triangular matrix. Now my question is, can you give an example for a black matrix, means square black matrix, which is not upper, which is not lower? Suppose you take this 0 0 2. You can take at least one non-zero, right? Above diagonal 0 0 2, 0 0 3. This is my black. Question is it lower triangle? No, not you know, black lower triangular matrix. Why? Above diagonal is 0 2 matrix. What is above diagonal matrix? You know, what is above diagonal matrix? 0 2. It is not a 0 matrix, not 0 matrix. Therefore, it is not a lower black lower triangular matrix. Now, can you give an example which is not upper triangle? 1 0 0. Suppose you take this 0 0 2. You can set at least one, right? Suppose you can take 2 here, 0 3. Right? So below the diagonal, you have a 0 matrix. Below the diagonal, you have a 0 2 matrix. That means it is non-zero matrix. As you know that it is a non-zero. As you know that it is a non-zero matrix. Non-zero matrix below the diagonal, which is below the diagonal, which is below the diagonal. Hence, it is not a black upper triangular matrix. Is it clear, all of you? Hello? Is it clear, Andy?
Yes, sir. Yes, sir.
Yes. Now, using this idea, we'll solve some problems. Suppose you are given a question. 1 2 3 0 0 0 0 1 0 0 0 0 0 0 2. So 0 0 and 0 0 0 1 0 0 0 0 0 0 2 3 0 0, 0, 0, 0. Sorry, you can take another element here. Of course, you can take anything. 1, 1. Find the determinant of this. What is the determinant of this? Right, it is actually what this is a 6 by 6 matrix, 6 by 6 determinant. Right? Right? What is the determinant of this? Once you compute this, it will take a laborious work, right? But the thing is, once you know the black matrices, you can easily calculate this determinant. Right? So what I do is that I can partition this matrix into blacks. Right? First, you need to cover the zero matrix. You know, this is zero matrix, 0, 0, 0, 0, 0, 0, 0, 0, 0. First, you need to cover this zero matrix by drawing horizontal and vertical lines. Therefore, once you call this as M, so this is looking like M is equals to A, 0 matrix, 0, B matrix. What is A? A is equals to, 1, 2, 3, 0, 1, 0, 0, 0, 2. My B matrix is 1, 0, 0, 0, 2, 3, 0, 1, 1. Now I need to, what is our aim? Our aim is to find det M. It is looking like a diagonal matrix, product of the diagonal entries. That means debts of the diagonals. What is det A? Det A is nothing but what? It is nothing but a upper triangular matrix. Upper triangular matrix for the det is product of the diagonals. So 1 into 1 into 2 is for det of A. Next, what is this? What is the det of B? 1
minus
into 2 into minus 3. Therefore, this is 2 into minus 1. Therefore, this is nothing but minus 2. So that is a power of blacks. That is a power of black. Understand? So once you know the black matrix, once you identify the blacks suitably, one can get determinant, of course, characteristic polynomial ladder and minimal polynomial ladder and Jordan max ladder. So this is a power of a block, right? Very important, interesting. Suppose you can take another example. 1, 2, 3, 4, 3, 4, 2, 1, 0, 0, 2, 1, 0, 0, 1, 1. Right? What is the data of this? Right? So my suggestion, first into form a block actually, right? Suitably. Right? So 1, 2, 3, 4, 3, 4, 2, 1, 0, 0, 2, 1, 0, 0, 1, 1. What is my block actually suitably? First you need to cover as soon as zero matrix. So by drawing this horizontal line and parallel line. Right? It is looking like a matrix, is A, B, C, 0, C. It is looking like upper triangular black, right? Black upper triangular matrix. Yes or no? It is looking like a black upper triangular matrix. Once you have a upper triangular matrix, right? This is dead, sorry. It's not a matrix. Right? So therefore, det of this black upper triangular matrix is nothing but det of A into det of C, product of the diagonal matrix. So det of A is nothing but what? What is det of A? 4 minus 6. Right? This into this, this into this. Similarly, what is this? This into this into this. 2 minus 1. That means minus 2, 1. Therefore, minus 2. Is it clear? So what is the basic idea? Basic idea is first form a black matrix suitably. Understand? That is important idea. You can take another example for understanding purpose. So 1, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, right? right? 1 1 2. Okay, next is 0 1 0 0 1 0. Next 0 1 2 0 0 1. Now what you do? What is the first step? Convert this data into black matrix. Now first you need to cover the zero matrix. Where is 0? Here 0 0 0 0 0 0 0 0. Right? It is looking like a matrix, black lower triangular matrix. This is A 0 B C. What is data of this? Data of A into data of C. Right? So therefore, what is data of A? What is data of A? Anybody? 1 into 0 minus 1. 1 into 1 into 0 minus 1 minus 1. What is data of C? You know, it is a there is at least one column which is 0. Therefore 0. Therefore 0 into something is 0. Is it clear? Right? So using this idea, right, in 2012 CSIR, there is a question. 2012 question. Suppose A is a 5 cross 5 skew symmetric matrix. Let A be a 5 cross 5
సార్ ఎవరిదో డిస్టర్బెన్స్ ఉంది సార్ చాలా
skew symmetric. Over the
Okay, sir.
skew symmetric matrix, right, with real entries, right, in R, and B is nothing but a symmetric matrix. B is symmetric matrix. Whose ijth entries is a binomial coefficient. Ij is a binomial coefficient where 1 less than or equals to I less than or equals to j less than or equals to 5. Consider a black matrix, 10 cross 10 black matrix, which is given the black form, right? Suppose you take this a plus b, and 0 to b. It is a black matrix. In fact, it's black upper triangular matrix. So then answer A, det C equals to 1 r minus 1, det C equals to 0. Answer C, trace of C is 0 and trace of C is equals to 5. Now tell me, Emma, what is that? Looking for the first option. What is A? What is A matrix?
Skew symmetric.
A is equals to 5 cross 5 skew symmetric. Therefore, skew symmetric means what? What is the det A equals to 0? It's an odd number. Once it is odd number, it is 0. Right? It's an odd. 5 is an odd. Generally, if you take an even, need not be, but it's an odd number. 5 is an odd number. Det A is 0. Right? So what is B actually? I don't know B, but what you do is that what is det C? Upper triangular, right? Black upper triangular matrix. So det of C is equals to det of A into det of B. But det A is 0. Det B is a what is this? Det B is a real number, because actually B already given it's a symmetric matrix. You can get any real number. If you can take any real number, right? 0 into real number is 0. Therefore, what is answer? Det C is equals to 0. No need to calculate det B. Understand? Because det B can be real number. No need to calculate det B. Is it clear? Because 0 something you are getting 0 into real number is always real 0. Therefore 0. This is 0. right? Now look at trace. What is the trace of this? Anybody? What is the trace of this? Trace of this is equals to trace of A plus trace of B. What is trace of A? Anybody? Yeah, what is trace of A?
0, sir.
0, because A is a skew symmetric matrix. A is looking like this: 0, 0, 0, 0, 0. Right? Trace of this, because it's a skew symmetric matrix, it is looking like this. So trace is 0. 0 plus. What is trace of B? What is my B matrix? My B matrix is symmetric matrix. You're looking for diagonal entries. You're looking for diagonal entries. Yes or no? You're looking for diagonal entries because I'm going to find the trace. So what is A11 entry? A11 entry is nothing but binomial coefficient 1, 1. What is A22 entry? Binomial coefficient 2, 2. What is A33? Binomial coefficient 3, 3. What is A55? Binomial coefficient 5, 5. 1, 1 is nothing but 1. 2, 2 is nothing but 1. 3, 3 is nothing but 1. 5, 5 is nothing but 1. 1 plus 1 plus 1 plus 1 plus 1 plus 1 up to 5 times. Therefore 5. So 5 plus 0 is equals to 5. So trace of C equals to 5. Is it clear? Hello, is it clear, all of you?
మళ్ళీ ఒకసారి ట్రేస్ బి.
So whatever, see, is it clear actually what is A matrix? A is a skew symmetric matrix, trace is 0. Is it clear, all of you? Is it clear? A is a skew symmetric matrix. Therefore, trace is 0. Because diagonal entries are 0 for skew symmetric, therefore trace must be 0. But what is B? My B is symmetric matrix. Yes or no? But we are looking for only diagonal entries. I don't. Is it clear? Yes. Now, so this is what actually beauty of black matrix. So very, very important. Now, determinants. So before going to determinants, there is a problem which is asked in CSIR. Yes. Is it audible? Hello? Is it audible, sir?
Yes, sir.
Audible.
Yeah. My net connection is unstable. It shows like that. So what is the depth of 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0. It is looking like this. 0, 0, 0, 0, 0, 0, 0. Right? -1 whole power n. Option B, -1 whole power step of n by 2. Option C, -1. Option D, 1. What you are given actually off diagonal elements, anti-diagonal elements. These are nothing but what? Anti-diagonal elements. You are given anti-diagonal elements. This question asked in CSIR. You are given anti-diagonal elements. I told you what is the formula for anti-diagonals? I plus j is equals to n plus 1. Right? This question asked looking, see this question asked looking like this, what is the depth of A where ijth entry of A is nothing but anti-diagonal elements 1 if I plus j equals to n plus 1, non otherwise 0. Understand what is the depth of this? One can ask this question. One can ask this question as like this. What is the depth of A? What the ijth entry of A is nothing but anti-diagonal elements are 1 or other entries are 0. Right? but don't confuse, right? Don't be confused. Yeah, tell me, how can you solve this? By induction. By induction, simple idea is induction. Suppose you take n equals to 1, I can take A equals to 1 matrix. You know, it is looking like this matrix, 1 by 1 matrix. What is data of 1? What is data of 1? 1. What is data of 1? 1. Therefore, this option failed because data of 1 is not minus 1. Similarly, this option also failed because for n equals to 1, what is minus 1 whole power 1? Minus 1. Right? This cannot be minus 1 whole power 1. Therefore, first option is also false. Option C false because you are going to get that A is 1. But what is this? Minus 1. What is option A? Minus 1 whole power 1 because I'm taking n as 1. Therefore, minus 1 whole power 1 is equals to minus 1. Therefore, this cannot be at A. Therefore, option A and C are discarded. Right? What are option B and D? Suppose you take A equals to, for n equals to 2, I can take A is looking like this. 0, 1. Right? Anti-diagonal elements are 1, 1. Remaining entries are 0. What is that A? 0 minus 1. That means minus 1. Therefore, this is discarded because the constant function det A equals to 1. What is this actually? Det A equals to 1. But what you are going to get, what you are getting actually here? Minus 1. But what is option D? Plus 1. So option D is discarded. Is it clear? So what is the possible size? B. Is it clear, all of you?
సార్ స్క్రీన్ కనిపించట్లేదు సార్
Screen
సార్
కనిపిస్తలేదు. Yeah. Sorry. నా నెట్ సంథింగ్ ఏదో ప్రాబ్లం అనిపిస్తుంది. ఒక నిమిషం. జస్ట్ వెయిట్. ఇప్పుడు కనిపిస్తుందా? ఇప్పుడు వినిపిస్తుందా? చెప్తుండండి. హలో.
నో సార్ లాస్ట్ లో వినపడలేదు.
నోనా? ఓకే.
టూ ఆప్షన్స్ డిస్కార్డ్ చేశారు సార్, ఏ అండ్ సి, తర్వాత వినపడలేదు.
యా.
ఒకసారి ఎక్స్ప్లెయిన్ చేయండి.
Okay. For n equals to 2, what happens? I can take the matrix as like this. Right? These are anti-diagonal elements. Therefore, matrix is of the form 0, 1, 1, 0. Because for n equals to 2, 2 cross 2 matrix, the matrix should be of the form 0, 1, 1, 0. Right? What is the det A? Minus 1. Right? So det A equals to minus 1. Therefore, option D is discarded. Right? Because option D is 1, but your answer is minus 1. Therefore, option D is discarded. Is it clear? Therefore, what is the possible choice? Option B. Is it clear?
ఎస్ సార్.
Yes. So this question asked in CSIR, right? Next is I'm looking for determinants, right? Now my topic is determinants. Right? So determinant is nothing but what? Once you are given a matrix, right? Score matrix or a field F. Determinant is nothing but what? Actually is a function actually. Scalar value function. Right? You take any matrix, data is a scalar. Data is a scalar, right? Data is nothing but actually what? Function from matrices to field. You give me any matrix, you're going to get a scalar, right? Suppose you take this. Suppose for n equals to 2 matrix, that means 2 cross 2 matrix, A, B, C, D, right? What is that? You know, AD minus BC. You know, it is a scalar. Once you give me matrix, I can get a scalar, right? Once you give me matrix, I can get a scalar. This is nothing but what? Det of 2 cross 2 matrices. For n equals to n bigger than equals to 3, how can you define that? How can define it generally? Using minors and cofactors, right? Now I'm looking for defining the determinant of a matrix whose order is bigger than equals to 3, right? Now instead of defining a determinants of a matrix whose order is 3, bigger than equals to 3, let us define minor. Suppose you are given a matrix which is a square matrix of n by n. Now minor, looking for minor of ijth entry is nothing but what? Simply, what is a matrix? A is looking like this: a11, a12, a13, a1n, a21, a22, a23, a2n, right? an1, an2. This is nothing but this is nothing but what? A matrix, right? What is a minor? Minor is nothing but simply, suppose there is some ijth entry is there. What you do is that delete this column, delete this row. So what is minor? Determinant. It's a determinant obtained from deleting, right? It's ith row and jth column of ijth entry, right? Minor is nothing but what? It simply is nothing but it is a determinant which is obtained from removing its ith entry, ijth row and ith row and jth column, right? Suppose you are given a matrix like this. Suppose you are given A equals to 4, 3, 1, 2, 4, 5, 1, 2, 1, right? Suppose you are looking for finding minor of 4. What is the minor of 4? Minor of 4 is nothing but entry 4, right? Delete this column, delete this row, right? What is the determinant? 4, 5, 2, 1. That is nothing but what? What is the determinant? 4 minus. I have defined actually determinant of 2 by 2 matrices. This is a definition, right? Data of A for 2 cross 2 matrices is nothing but AD minus BC, right? So therefore 4 minus 10, that is equals to minus 6. Similarly, one can compute all the minors. Suppose you are looking for minor of, suppose 4. Minor of 4 is nothing but what? Minor of 4 is nothing but this row, this column, this row discarded 4, 4, 1, 1, 1, right? Therefore 4 minus 1, that is equals to 3. This is what actually minor, right? Next is cofactor. అట్లీస్ట్ ఒక్కో క్వశ్చన్ 2 క్వశ్చన్స్ అయినా అట్లీస్ట్ ఎవ్రీ టైమ్ సిఎస్ఐఆర్ గేట్ లో డిటర్మినేషన్ క్వశ్చన్స్ వస్తాయి కంపల్సరీ. కాబట్టి చాలా బాగా ప్రాక్టీస్ ఉండాలి, దీని మీద బిట్స్ ఎక్కువ చేయాలి. అట్లీస్ట్ ఒక్కో క్వశ్చన్ ప్రతిసారి అట్లీస్ట్ 1-2 క్వశ్చన్స్ కంపల్సరీ వస్తాయి. సో కోఫాక్టర్ ఆఫ్ అన్ ఎలిమెంట్ cofactor, simply cofactor, right? So you start with a n by n matrix, means that square matrix. Cofactor is nothing but what? Cofactor is simply denoted by Cij, right? Cofactor of ijth entry simply is nothing but is defined by -1 whole power I plus j, right, into its minor, right, where mij is minor. Right? Suppose you are given a matrix like this. Same matrix, suppose you take this 4, 3, 1, 1, 3, 2, 2, 1, 5. Right? Now I'm looking for computing the minor of 4. What is the minor of 4? We have seen already. What is the cofactor of 4? For suppose you take k11 is equals to 4. What is the cofactor of 4? Means -1. So where is sitting in? Actually, it is sitting in first row and first column. 1 plus 1 in corresponding minor. Corresponding minor is 3, 2, 1, 5. That is equals to 15 minus 2. That is equals to 13, right? So this is what actually my cofactor of corresponding entry A11 entry. Similarly, if you compute, suppose you're going to compute A12 minor of A12 entry, means cofactor of A12 entry, means -1 whole power 1 plus 2 into its corresponding minor, right? I'm looking for finding a cofactor of A12 entry. So delete this row and delete this column, right? What is this? 1, 2, 2, 5. That means -1, 5 minus 4. That means what? -1. So this is what actually our cofactor, right? Similarly, one can compute all cofactors. Now, what is my definition of determinant? Determinant of a matrix for determinant of matrix whose order n is bigger than equals to 3, right? What is my formula? Determinant of A is simply denoted by like this, or det of A. So simply, sum of products of elements of any row or any column with the corresponding cofactors of such row, such column, that row or column, right? Suppose you take this is my, suppose you take this for instance, you take a, for example, 3 by 3 matrix, right? So what is the det A? Det A can be computed along the row or column, What is the formula? A1 into its corresponding cofactor. A1 is actually, where is located? It is located at 1 plus A11 its cofactor plus B1 corresponding cofactor plus C1 its corresponding cofactor. Or else det A can be computed along the column also. A1 into corresponding cofactor, A2 into corresponding cofactor. A2 is sitting inside 2-1 entry. Therefore, this is 2-1. Therefore, next A3, its corresponding cofactor. A3 is located at 3-1 entry. Right? So det can be computed along the row or column with the corresponding cofactors. Suppose you take the det like this. Suppose you take det suppose A1 with a different cofactor, A21. Suppose you take A31, A3 into A22. What is this? 0. What is this? 0. With the same row, same column. This is important. Right? A1, where is A1? Actually, it is located at 1-1 entry. You need to multiply with the corresponding cofactor, or else it is 0. Right? Already in basic intermediate degree, easily one can compute it. So this is 0. This this is 0. Total, this is 0. Right? You can easily compute it. Right? So that is nothing but what? Sum of products of elements of any row with the corresponding cofactors of that row. మీరు ఏ రోతో అయితే వర్క్ చేస్తున్నారో ఆ రోతో చేయండి, ఆర్ ఎల్స్ ఇట్ ఈస్ 0. దిస్ ఇస్ ఇంపార్టెంట్. It is 0. Right? Next is nothing but actually, suppose you take this matrix. Suppose you take A is equals to 1, 0, 1, 2, 1, 3, 4, 5, 6. You are asked to find what is det A. What is det A? 1 into 6 minus 15. You know this technique already. I don't want to do this. So 12 into 12 minus 12 plus 1 into 10 minus 4. Therefore, this is nothing but what? What is this? Minus 9 plus 6. Right? It's nothing but minus 3. This is non-zero. Right? So this is nothing but like this. You need to compute it. This is nothing but one element, its corresponding cofactor. This is the cofactor. This is cofactor. This is cofactor. Right? I am evaluating the determinant along this row. Along this row. Right? You can evaluate the determinant along any column or any row suitably. Right? Now looking for properties. I don't want to waste my time because you know these properties. Right? So first property, right? If rows and columns of a determinant are interchanged, then the value of the determinant is not changed. Means suppose you are going, for instance, you can take this A1 B1, A2 B2, C2, A3 B3, C3, right? Suppose you can take this as det, right? This is A2, this is P3, this is nothing but a det. Suppose you can take this, that det is delta. You can take another delta by interchanging the rows. This A1, interchanging the rows and columns. A1 B1 C1, A2 B2 C2, next A3 B3 C3, interchanging the rows and columns. So what you observe is del is equals to del prime. Del is equals to del prime, right? You know this property. By changing the rows and columns, the det value should not be changed, right? Or in fact, notice, or in fact, in general, what is meant by this? Or in fact, what is in fact, you know, det of a matrix is same as saying this tells you that det of a matrix is nothing but det of A transpose for any square matrix using this concept, right? Det of A is equals to det of A transpose, right? Because by changing the rows and column, the determinant does not change. Therefore, det of A is equals to det of A transpose, right? Now, second property, if you change only two rows or two columns, suppose any two rows or columns, change only two rows or columns of a determinant are interchanged, then the value, in fact, the sign of the new determinant, new det value, determinant is changed. Means if you take, for instance, you take A1 B1 C1, A2 B2 C2, A3 B3 C3, right? No, this is a matrix, this is a determinant. You take this as delta. Suppose you change two rows. Right? A2 first row and second row. A2 B2 C2, A1 B1 C1. Next A3 B3, keep it as it is. You know what you observe is del dash is equals to minus delta. Understand? So suppose you change any two rows or columns, the resultant determinant is changed by minus sign. Right? So this is interesting property. Third one, if any two rows as columns of a determinant are identical. In fact, actually proportional. No need to be identical. Proportional. Then value of the determinant, its value is 0. Right? Suppose you take this delta as a1, b1, c1. This is k1, a1, k into a1, k into b1, k into c1. Just keep it as it is. A2, this is a3, b3, c3. What you observe is these two rows are proportional. A1, b1, c1. This is k1, kb1, kc1. These two rows are proportional. So we observe that this value is 0. This value is 0. And fourth one, if any row or column is a 0, 0 column, then its value is 0. Column of a determinant, its value is 0. Suppose this column is 0, is a1, b1, a2, b2, is a3, b3. What is the value? 0. Suppose that there is at least one column or row which is in the determinant which is 0 column or 0 row whose value is 0. Next is, suppose you have a elements. You have elements of any row, or column are multiplied by a scalar, any scalar, any row or any column of determinant. You need to write determinant. Are multiplied by a scalar, then the new determinant, in fact the value of the determinant, then the value of the determinant is that scalar times the same scalar. In fact, the same scalar times of the old given determinant. In fact, old determinant. Suppose you are given this a1, b1, c1. This row is multiplied by a constant k, scalar k. Remaining rows are as it is. So what you observe is, suppose you are another determinant a1, b1, c1, a2, b2, c2, is a3, b3, c3. What you observe is, del is equals to k into del dash. Right? This is what our new delta. This is nothing but the old one. Suppose you assume this. So del is nothing but k into del 1, right? Del dash. So using this result, see k is in the only first row. Suppose k is in the all rows. What you observe? Therefore, in fact, det of k into a is equals to k power n into det a. Whenever a is any square matrix whose order is n by n, you can take any scalar. Understand? Using this result, k, what is k into a? K into a means what? The matrix which is obtained by multiplying each element by k, scalar k. Therefore, you are getting here k, here k. Once you have a k in a row, you can take outside. Similarly, k in the second row, therefore you can take outside. Similarly, the k in the third row, you can take outside. How many k's? k into k into k into k into k into k n times. Therefore, k power n into decay. Right? This property is very, very important. Right? Next is, suppose your element, next property number 6. If each element of a determinant, right, is the sum of two elements, then the determinant is expressed as sum of two determinants of same order. That means, suppose you are a det like this: a1 alpha, b1 beta, a1 alpha, b1 beta, means a1 plus alpha, b1 plus beta, c1 plus gamma is a2, b2, this kept as it is, a3, b3, c3. Now what you do is, this can be seen over here. This first row is in first row each element is sum of two elements. This is nothing but a1 plus alpha. There are two terms. This each element, looking at a first row, look at first row. What you observe is each element is the sum of two elements. Therefore, this can be expressed as a1 b1 c1, a2 b2 c2, next a3 b3 c3 plus alpha beta gamma a2 b2 c2, next a3 b3 c3. This is what actually property, right? If any row, any column in which each element is expressed as a sum of two elements, then we can express it as like this: any row, any column in which each element is expressed as a sum of two elements, then what you do is that can be expressed as that, the determinant can be expressed as the sum of two determinants of same order. That's what my point. Right, next one is property number 7. So we can do the row operation. That means if each element of a row or column be added equimultiples of corresponding elements of one or more rows or columns, then value of the determinant is not changed. Value of determinant is not changed. That is, suppose, that means if you apply this row operation or column operation, if you replace, simply one can write like this in notation. If you replace s row by s row plus some kth row plus tth row, the determinant does not change. If you replace s row by s row plus some kth plus k into tth row, the determinant does not change. That's what actually operation. That is, if you replace s column by s column plus tth column, the resultant determinant does not change. That is the meaning, right? If you replace s row by s row plus k times tth row, the resultant determinant does not change. That's what actually argument, right? And last one, finally, det of product of two matrices is nothing but product of the debts. Already we know this, right? Det of the product of matrices is nothing but product of the debts. Now, Let us solve some problems using this. Right? First question. Det map, we have seen actually det. What is det? Det is actually what? Lean is a map actually. Is a map. Question is it a linear map? Is it a linear transformation? It's a vector space. We'll see later. It is a vector space. N cross N matrices or a field F is always vector space. Every field F over F itself is also vector space. It is a map from vector space to another vector space. Question is that is it a linear transformation? Is it a linear map? The answer did not be. Means it fails to satisfy the first one. Means what? It does not preserve the vector addition. This map does not preserve the vector addition. Means what? Det of A plus B may not equals to det of A plus det of B. It does not preserve the vector addition property, right? So can you give example? Can you give me such a suitable AB? Anybody? Can you give such a suitable AB? Yeah. Can you give me any such suitable AB? Anybody? A equals to 1, 0, 0, 1. B equals to -1, 0, 0, -1. What is A plus B? A plus B is nothing but 0, 0, 0. Therefore, det of A plus B is nothing but 0. What is det A? Det A is nothing but AD minus BC. Therefore, 1. What is det B? Det B is nothing but 1. Therefore, det of A plus B is actually what? 0. But which is never equals to 1 plus 1. This is nothing but det A plus det B. Therefore, what you observe is det map is not linear. Are you there? Hello? Are you following? Hello?
Yes, sir.
So det map is general, not linear. So using this idea, right? So this question asked in CSIR 2020. Right? Suppose you are looking for, you are given a two matrices which are 2 by 2 matrices, square 2 by 2 matrices. Then which of the following is true? First one, det of A plus B plus det of A minus B equals to det A plus det B. Second is det of A plus B plus det of A minus B equals to 2 times of det A plus minus 2 times of det B. Next, det of A plus B is plus det of A minus B equals to 2 into det A plus 2 into det B. Next, D, det of A plus B minus det of A minus B equals to 2 into det A plus minus 2 into det B. Right, already we have seen in metric spaces technique, suppose there is a minus, we can have some problem. Right, there is a minus sign in triangle inequality also. Suppose there is a minus sign, we have seen in a metric space, there is a problem. Right, we need to give a counter actually. So what are A and B? A and B are actually 2 by 2 matrices. And look for actually det A and det B. So we'll solve this problem in 2 ways actually, by straightforward or else you need to give a counter example. Right? Suppose you can take a matrices. A is equals to, suppose you can take this 1 0 0 1. One way I'm going to take A equals to 1 0 0 1, B equals to 0 matrix. Right? This is first method. Right? What is A plus B? A plus B is also 1 0 0 1. Therefore, what you observe is det of A plus B is nothing but identity matrix det 1. Similarly, what is det A? 1. What is det B? 0. Therefore, question is, it is actually what? Det of A plus B is actually what? 1. Det of A minus, what is A minus B? Anybody? A minus B also 1, 0, 0, 1. What is det of A minus B? Same 1. It is 1. Det A is actually what? 1. It is 0. Question is 1 plus 1. Is it equals to 1 plus 0? No. Therefore, it is discarded. 1 plus 1 is equals to 2 actually. This 1 plus 1 is equals to 2, which never equals to 1. Right? Therefore, 1 is discarded. Right? Similarly, go for this. This is 1. What is this? This is 1. This is 1. This is 1. This is 2 into det A. 2 into 1. This is 0. Therefore, this minus this is equals to 2. But this equals to 1 plus 1. It is also 2. So it can be true. We'll see later. It can be true. What is this? We'll see actually. I'm not concluded it. So what is det of this? Det of A plus B is 1. Det of A minus B is what? 1. This is what actually? 2 into 1, 2. 2 into 1, 2. Yes or no? Det of A plus B is what actually? 1. This is det of A minus B is what? What is det of B? Sorry, 0, right? So therefore, this also 1 plus 1 is equals to 2. So left side 2, of course, right side also 2. Therefore, it can be true. We'll see later which is true or which is false. What is this? Det of A plus B is actually what? 1. This is 1. 1 minus 1 is 0. This is 1. 2 into 1, 2. This is nothing but what? 2 minus 0. This is 2. So right side is 2, left side is 0. This is discarded. Right side is 2, left side 1. Therefore, this is discarded. Now check for B and C again. I'm going to take A equals to 1, 0, 0, 1. B equals to 1, same matrix, 1, 0, 0, 1. Now what I observe is, what is det of A plus B? A plus B is actually what? 2, 0, 0, 2. What is A minus B? 0 matrix. Therefore, det A is equals to 1. Det B is also 1. Det of A plus B is equals to 4. Det of A minus B is equals to 0. Now check with these options. Look for this. What is this det of A plus B? 4. This is A minus B is 0. What is 2 into det A? Det A is 1. 2 into A, det A is 1. 2 minus, what is det B? 1. 2 into det B is nothing but 2 minus 2, 0. Therefore, left side is 0, right side is 4. Therefore, this is also discarded. Therefore, the only possibility is this one. This is by options, by taking a counter example. But what is a straightforward method? It's an exercise. You can do it simply. You can take A is equals to A1. You can take this. A equals to A1, A2, right? A3, A4. B is equals to, B1, B2, B3, B4. Now what you do is, what is my det A? My det A is A1, A4 minus A2, A4, A2, A3. What is det B? B1, B4 minus B2, B3. What is A plus B? Det A? A plus B is nothing but A1 plus B1, A2 plus B2, A3 plus B3, A4 plus B4. What is A minus B? A minus B is simply A1 minus B1, A2 minus B2, A3 minus B3, A4 minus B4. So what is my det A plus B? It's A1 plus B1 into A4 plus B4 minus A2 plus B2, right? Next, A2, A3 plus B3, right? Next, what is det of A minus B? Det of A minus B is equals to det of A1 B1 A4 minus B4 minus A2 minus B2. Next, A3 minus B3. Now compute this. Go for option 1, go for option 2, go for option 3, go for option 4. Now easily observe that this is all options are discarded. You are going to get only C option. This is long procedure. Right? Go for A plus B, go for A minus B. This is a proof actually. Proof of the problem. Proof is very difficult to do this in exam. It takes time. So don't do this method. Understand? This is actually what, take A plus B, take A minus B, look for look for options. It is quite actually difficult to do in a exam. Don't go this method. Understand? It is a proof actually. It is a proof. It is a textbook proof. Don't do this. What is my suggestion is go for take a suitable matrices which is discarded or not. That is important. Right? It is a guess only. It is a guess. Right? Now, is it clear all of you? Hello?
Okay, sir.
Now, this question asked in CSIR, problem number 2, CSIR 2019 actually, this question. Take any real number, m of t is equals to 1t 0, 1t t square, right, 0, 1, 1, right? Which of the following is true? Option A, det A, det m is a polynomial of degree 3. Second option, det m is 0 for all t. Option D, det m is 0 for infinitely many t's, real t's. Det B, det m is 0 for exactly 2 reals, 2 t's. Yeah, now tell me, what is my det? Compute this. This is exactly 1 into t minus t square minus t into 1, 1 minus 0. Right? This is nothing but t minus t square minus t. It is a polynomial of degree 2. Right? What you're going to get? This is minus t minus, right, 1 t 0, 1 t t square 1 1. Therefore t minus t square minus t into 1. Therefore what you're getting? Yeah, we have done somewhere mistake actually. Okay. Yeah. Thing is actually this tt cancel. What you observe is this is t square. Okay, ఈ ప్రాబ్లం తోనే చేయండి. బట్ ఇక్కడ నేను మిస్టేక్ చేయొచ్చు, ఇక్కడ ఏదైనా సంథింగ్ మైనస్ పోవచ్చు, బట్ ఈ ప్రాబ్లం తోనే చేద్దాం. లెట్ us go this. See, this is a problem, polynomial of degree 2. Therefore this option is discarded. What you are given is actually in a problem det m is a polynomial of degree 3, but you are given in an option, but you are going to get actually what you are getting is a polynomial of degree 2. Therefore this is discarded. Next is det m is 0 for all t. Absolutely wrong. Det is 0, det m is 0 if and only if t square is 0 minus t square is 0. Therefore t equals to 0. This is det is 0 for only 0 value, but for all not t, right? Suppose you take t equals to 1, is it 0? Suppose you take t equals to 1, what is my det? My det of m is equals to minus 1 t minus 1 square, that means minus 1. Therefore det m should not be 0 for all t. Therefore this is discarded. Det m is 0 for only t equals to 0, and det m is 0 for infinitely many t's. Absolutely wrong, because det is 0 for only t 0. Only 0, only one value. Det m is 0 for only one value, 0. In fact 0 0. Right? 0 is a root with multiplicity 2. Right? 0 0. Therefore, but what you are given is that you are given det is 0 for infinitely many t's. Absolutely wrong, because det is 0 for only 2 zeros, 0, 0, multiplicity 2. Therefore, this is discarded. So what you're given is det m is 0 for only exactly 2 t's. Absolutely right, because 2 t's means 0, 0. Is it clear? This is such a simple question asked in CSIR 2019. Is it clear? Hello?
Okay, sir. Okay, sir.
Yeah. Next is, suppose you are given a question like this. This question asked in JAM.
Sir, in the fourth option,
Yeah.
det is 0 for t is equal to 0, only 1 0 in this.
0 t square is 0 means what? 0 t equals to 0, 0.
Yeah,
Any
yeah.
polynomial of degree 2 has at most 2
Second
roots.
degree question. Okay.
Yeah. Yes, sir. So this question asked in JAM.
సార్ కొన్ని క్వశ్చన్స్ ఇవ్వండి సార్, వాళ్ళు మనకు వాట్సాప్ గ్రూప్ లో పెడతారు. ట్రై చేద్దాం, రేపు నెక్స్ట్ క్లాస్ లో డిస్కస్ చేద్దాం.
ఓకే సార్, ఓకే చెప్తారా సార్? మీరు చెప్పేసాను. ఓకే, కట్ చేస్తున్నాను క్లాస్.
నో సార్, మీరు
Ah.
క్వశ్చన్ ఇవ్వండి, ఇక టైం కూడా అయిపోతుంది. కొన్ని వాళ్ళు
Yeah.
వాట్సాప్ గ్రూప్ లో ఆన్సర్ పెట్టమని.
ఓకే సార్,
దట్స్ బెటర్, ట్రై చేస్తారు వాళ్ళు.
ఓకే. యాక్చువల్లీ ఇంటరాక్షన్ ఉండాలి, బట్
అందుకోసమే మనం జ్యోతి మేడం, శిరీష మేడం వచ్చారా? శిరీష మేడం, జ్యోతి మేడం.
సార్
ఇంకో కొన్ని అసైన్మెంట్ కింద తీసుకోండి, గ్రూప్ లో పెట్టండి, తర్వాత సార్.
ఓకే సార్.
వెరీ బ్యూటిఫుల్ ప్రాబ్లం, లైక్ ఆర్డర్ ఉంటుంది 19, 91, 91, 92.
రైట్, చేయండి అమ్మా.
Can you guess anybody answer this one? Third answer. Determinant of this value. I think Satish గారు చేయగలుగుతారు అనుకుంటా. Satish is there? Okay.
Sir, yes, sir. -1 answer, sir.
Hello?
-1 answer, sir.
No.
Okay. Next question కూడా ఇవ్వండి సార్. ఓకే సార్, మీరు డిస్టర్బెన్స్ వస్తుంది సార్, మీరు మాట్లాడాలి, మీ సిగ్నల్ సరిగా లేదు సతీష్ సార్.
This question asked in JAM. Det of ABC, BCA, CAB is whenever A and B, C are distinct positive numbers, then answer A is negative, answer B is positive, answer C 500, answer D none. Yeah, this question asked in JAM. Tell me which option is right. Hello? Anyone trying?
Yeah, all of them are trying sir, seriously.
నెగటివ్ సార్.
Negative, good. Who said?
స్నేహ.
Me? Oh, Sneha, good. Right, this answer is right. Absolutely. So you can check random. You can take random. You pick A, B, C, distinct positive real numbers. You can check the answer. Or else you can go for proof. There are two ways. What you do is that go A and A equals to something, B equals to something, C equals to positive real number. Then compute ABC. Data of ABC, BCA, CAB. Then what you observe? 1, 2, 3.
నెగటివ్ సార్.
Negative determinant.
2, 3, 1, 3, 1, 2. What you are getting? 1 into 6 minus 1, minus 2 into 4 minus 3 plus 3 into 2 minus 9. What you observe is 6 minus 2, right?
5 minus
Minus 21. So it is negative, right? Or else what you do is that go for the proof. It is also easy by proof. See, once you compute this, what you're getting generally A into CB means BC. This is textbook proof. Minus B into B square minus AC plus C into AB minus C square. Right? Therefore, what you observe is ABC 3ABC. Right? Next, minus A cube minus B cube minus A cube. That is same as saying that A cube plus B cube plus C cube minus 3ABC. What is this? Minus of A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. Is it right? But this is exactly, precisely, this is minus of, you can, what you do is that A plus B plus C by 2 and multiply and divided by 2, 2A square, 2B square, 2C square. Next, what you do is 2AB, 2BC, 2CA. Right? Therefore, A plus B plus C by 2. Right? What is this? So this can be written as A minus B whole square, B minus C whole square, plus C minus A whole square. Right? Therefore, you know, A and what you are given, A and B are distinct. And what you are given, A positive, B positive, C positive. Once A and B are positive, distinct, at least two of them different. Therefore, at least this is positive, or this is positive, or this is positive. You know, this is always positive because A, B positive, C positive. This is positive. This one is positive. Sorry. This one is positive. This is always positive. This piece is positive, and at least one of them is positive. At least this in the second bracket is positive because at least two are different among three. So this is positive. At least one of them is positive in the second bracket. So positive into positive, positive, positive into negative, negative. So total is negative. So this is textbook proof. This is also easy. We can go through any argument.
Last problem answer 0, sir.
No, it is
Sir,
negative.
one more doubt, sir. Iday problem lo, sir. Iday problem lo, if he is not mentioned ABC are positive.
ABC పాజిటివ్ కాలేదని మెన్షన్ చేశాడు అనుకోండి, అప్పుడు చెప్పరేం ఇది పాజిటివ్ అయింది, ఇది నాన్ నెగిటివ్ అవుతుంది, దీంతో ప్రాబ్లం లేదు. బట్ థింగ్ ఏంటంటే దీంతో నచ్చలేదు, దీంతో ఎట్లాంటి గెస్ చేయలేం, A ప్లస్ B ప్లస్ C తో ఎట్లాంటి గెస్ చేయలేం. నన్ను అని పెట్టాలి అంతే. ఏబిసి మీద గెస్ చేయరాదు కాబట్టి నన్ను పెట్టాలి. యా, ఈ సెకండ్ బ్రాకెట్ తో మనకి ఎట్లాంటి ప్రాబ్లం ఉండదు బికాజ్ ఇట్స్ ఎ నాన్ నెగటివ్ టర్మ్. ప్రాబ్లం విత్ ఓన్లీ ఫస్ట్ టర్మ్.
ఇట్లా కూడా అడగొచ్చా సార్? ఇఫ్ det is equal to 0 then what is a cube plus b cube plus c cube?
అట్లా కూడా అడగొచ్చు. ఒక క్వశ్చన్ మనం డిఫరెంట్ గా, అందుకే గెస్ పవర్ ని పెంచుకుంటే బెస్ట్. యా,
ఆన్సర్ చెప్తున్నారు సార్, అది కరెక్టేనా?
చెప్పండి సార్, చెప్పండి. హలో సార్.
0 సార్.
యా, దట్స్ రైట్. హూ సెడ్?
స్నేహ.
యా, సేమ్.
ఇంకా ఎనీబడి? లాజిక్
ఓన్లీ
1900 ప్లస్ అన్ని
ఓన్లీ ఇద్దరే రెస్పాండ్ అవుతున్నారు. ఒకరు
రో ఆపరేషన్ సార్ అది.
Yeah, row operation using the sixth operation. You know, we have said all the properties. What you do is applying R2 minus R3 minus R2. What you get is 1990, 1991, 1992. This keep it as it is. This is keep it as it is. This is keep it as it is. What is it? You are going to get 1, 1, 1. And similarly, what you do? Applying the same row operation, R2 minus R1. So therefore 1990, this, there is no problem with the first row. This is what actually 1, 1, 1, 1, 1, 1. You know, two rows are identical.
2 rows are identical.
0. It is looking like a big problem, but once you apply the row operation, it is coming to the different simple problem.
లేదంటే ఇప్పుడు ఇస్తే 2021 22 కానీ స్టార్ట్ 23 స్టార్ట్ చేయొచ్చు 2020
Yeah.
21
అట్లా చేంజ్ చేయొచ్చు. రైట్. సపోజ్ ఇదే ప్రాబ్లం, ఇది కూడా గేట్, ఇది ఇంత ముందు వచ్చాడు గేట్ లో ఈ ప్రాబ్లం. లుక్ ఫర్ దిస్. సో ఇంత ముందు గేట్ లో ఇచ్చాడు -7 5 + 3i 2 - 3 4i 5 - 3i 8 4 + 5i 2/3 + 4i is 4 - 5i 9. So option A purely imaginary, option B purely real, option C A + IB where B is non-zero, option D A + IB where B equals to 4. Now tell me which option is right. Yeah, anybody? Are you following? Are you trying?
Yeah, sir. They are doing, sir.
Yeah, okay.
చంద్రయ్య మౌనిక
అందరు రెస్పాండ్ కండి, అందరు
రెస్పాండ్
రెస్పాండ్
కావాలి. సునీత, మౌనిక చేయాలి వాళ్ళు. చిరంజీవి
డూయింగ్ సార్.
సార్ కంప్లీట్ గా ప్రసాద్ సార్కి ఇచ్చేది నెక్స్ట్ సెషన్. బి ఆప్షన్ ఇస్ సేయింగ్ చంద్రయ్య, చిరంజీవి సేయింగ్ బి ఆప్షన్ ప్యూర్లీ రియల్.
ఆప్షన్ చాట్ బాక్స్ లో పెట్టారా సార్? ఓకే,
చాట్ బాక్స్ లో పెట్టండి, చూద్దాం సార్. అబ్జర్వ్ చేయండి. డోంట్ సే ఆన్సర్ ఫస్ట్.
యా సార్, ఓకే సార్.
వసంత సౌమ్య వెంకన్న సేయింగ్ స్వప్న మేడం ఫ్రమ్ ఆదిలాబాద్. రోజు వింటూ రాస్తా ఉన్నారు, ఇప్పుడు మీకు పని ఇచ్చారు. Majorities are saying B option. It's like conjugates కనపడుతున్నాయి కదా సార్. 5 + 3i conjugate 5 - 3i 2/3 - 4i.
Yeah sir, that is the trick behind the
yes
problem.
exactly. Yeah, ఎవరైనా యూజ్ చేస్తారండి ట్రిక్? అది ప్రాబ్లం చేస్తున్నారు.
లేదు సార్, అదే ట్రిక్ యూజ్ చేస్తున్నాం సార్.
ఎందుకంటే కాంజుగేట్స్ ఉన్నాయి. 5 + 3i conjugate is 5 - 3i.
అదే సార్.
That's correct.
Shivaji sir,
Shivaji.
Armission, okay, but why option B?
Respond, Shivaji, respond.
Sir, it's Hermitians.
Okay.
Is it A or B? It is confusion, sir.
Yeah.
Confusion is there, sir. It is A or B.
Okay.
I didn't listen that class, sir.
Okay.
శివాజీ రాజ్ కుమార్ ఉన్నాడా?
సార్ ఉన్నారు
రాజ్ కుమార్ ఓకే, రాజ్ కుమార్ మాట్లాడతారు.
సార్.
మౌనిక ఆన్సర్ ఇస్తుంది. సౌమ్య చేస్తున్నావా? ప్రాబ్లం చేస్తున్నావా? ట్రై చేయి.
ట్రై చేస్తాను.
ఆప్షన్ సి సార్.
Who said option C? Monica. Why?
In all terms 5 plus 3i imaginary part and real part there, sir. In option C, b not equal to 0, we have the form a plus id, so that's why I said.
No, is it a argument? See, how to find the determinant? What is the dead value?
Anymore else? ఇంకెవరైనా? Okay, sir. Give the clarification.
Yeah. See, this is actually what. Suppose you take this as a z. It's a complex number. Once you assume this, what is z bar? Anybody? What is z bar?
-7, 5 - 3i.
2 plus 4i.
5 plus 3i.
5 plus 3i. 8. This is 4 minus 5i. Next. 2 by 3 minus 4i. 4 plus 5i. 9. Now, can you guess? Can you conclude anything?
Sir, z bar is equal to real part, sir.
Z bar is equals to? Is it
Z
Z?
into z bar is equal to real part.
Yeah. Is it real number? Right side? Is it Z? Is it Z?
It is real part only. Real part, sir.
No. My question is it actually Z? Right side is Z. Z actually need anukunnam kada. Is it right side undi Z?
1 by z, sir.
1 by z.
Why 1 by Z?
Z
Here,
bar
Z
equal to 1, sir.
See, actually, in right side unna determinant Z antuna. Right side unna determinant Z antuna. Right? అర్థమైందా మీ క్వశ్చన్? అర్థమైందా? నేను చెప్పే క్వశ్చన్ అర్థమైందా మీకు? ఇది రైట్ సైడ్ ఉంది జెడ్.
Yes, sir. Given.
జెడ్ అంటే యాక్చువల్లీ ఇది అనుకున్నాను. జెడ్ బార్ అంటే ఇది అయిపోయింది. Therefore, does it mean that it equals to Z?
No.
How can you say that it is purely real? Purely real అని ఏం చెప్పలేము, రైట్? Purely real అని ఏం చెప్పలేము. Is it clear? So is it Z? Actually, no. Is it Z? No. Therefore, Z bar cannot be Z. Therefore, is it real? Is it purely real? If Z is equals to Z bar, it is real.
Okay, sir.
Z is equals to Z minus Z bar is equals to minus Z. It is purely imaginary. ఈ రెండు కేసెస్ యాక్చువల్లీ వర్కౌట్ అవుతాయా చెప్పండి? Is it equals to minus Z? Anybody?
No, sir.
No. సో కాబట్టి ప్యూర్లీ ఇమాజినరీ కూడా కాదు. ఇన్ఫాక్ట్ అసలు ఏ ఆప్షన్ కూడా రాదు. ఇన్ఫాక్ట్ చెప్పాలంటే ఏ ఆప్షన్ కూడా కరెక్ట్ గా సూటబుల్ కాదు. సో పాసిబుల్ ఆప్షన్స్ ఏంటి? ఏ ఆప్షన్స్ కూడా యాక్చువల్లీ చెప్పాలంటే ఇక్కడ ఏ ఆప్షన్ కూడా ఉంటుంది నన్. రైట్? ఏది కూడా గెస్ చేయరాదు. అండర్స్టాండ్? ఇది క్లియర్? కాకపోతే ఇక్కడ థింగ్ ఏంటంటే ఆప్షన్ లో ఇంకొక ఆప్షన్ ఇక్కడ మీరు కనుక సూటబుల్ కనుక పెట్టారనుకోండి, ఫర్ ఎగ్జాంపుల్ ఏమి ఇచ్చాను? ఫర్ ఎగ్జాంపుల్ నేను చేంజ్ చేశాను అనుకోండి, ఫర్ ఎగ్జాంపుల్ ఇక్కడ ప్లస్ వచ్చేటట్టు చేంజ్ చేశాను అనుకోండి, ఫర్ ఎగ్జాంపుల్ z is equals to -7 5 - 3i 2/3i. ఫర్ ఎగ్జాంపుల్ ఇదే ఆప్షన్ తీసుకోండి, i this is 5 - 3i 8, రైట్. ఇది కూడా చేయరాదు లేండి, ఇది కూడా చేయరాదు, రైట్. ఇక్కడ కూడా చేయరాదు, ఇక్కడ కూడా అడ్జస్ట్ చేయరాదు. ఇస్ ఇట్ క్లియర్ ఆర్గ్యుమెంట్?
సార్ ఇంకొకటి సార్ ఇక్కడ సి ఆప్షన్ చూసినట్లయితే a plus ib b not equal to 0 ఉంది. దిస్ ద కేస్ ఆఫ్ ప్యూర్లీ ఇమాజినరీ కూడా పాసిబిలిటీ ఉంది కదా సార్ ఇందులో?
ప్యూర్లీ ఇమాజినరీ పాసిబిలిటీ లేదు సార్, ఎందుకంటే ఏ జీరో అని ఇవ్వలేదు కదా, ఏ జీరో ఇవ్వలేదు కదా.
అంటే ఏ ఇస్ ఎనీ రియల్ నెంబర్, అంటే ఇక్కడ ఏంటంటే ఈ ఫస్ట్ ఆప్షన్ తోటి దీన్ని క్యాన్సిల్ ఇది కాదని చెక్ చేసుకోవడానికి అని చెప్తున్నాను, డిస్కార్డ్ కావడానికి.
ప్యూర్లీ అంటున్నారా? ఇది యాక్చువల్గా ఇది ఎనీ కాంప్లెక్స్ నెంబర్ కావచ్చు, ఇది కూడా అసలు గెస్ చేయలేము కదా. ఇప్పుడు ఇక్కడ
ఈక్వల్ టు 0 మెన్షన్ చేశాడు కాబట్టి ఏ మేబీ ఐదర్ ఈజ్ ఈక్వల్ టు 0 కూడా కావచ్చు కదా. అట్లాంటప్పుడు ఏమైతుంది, ఇది ఐబి ఇమాజినరీ పార్ట్ అవుతుంది, ప్యూర్లీ ఇమాజినరీ అవుతుంది. అప్పుడు ఇది కూడా కావడానికి స్కోప్ లేదని డిస్కార్డ్ చేయొచ్చు కదా.
ఓకే, ఏ అనేది యాక్చువల్గా నాన్ జీరో, ఏ ఈక్వల్స్ టు 0 తీసుకున్నప్పుడు యాక్చువల్గా ఇదే కేసు వస్తుంది అంటున్నారా?
ఎస్ సార్. అప్పుడు కాబట్టి ఇది కూడా ఒక కేసులో పాసిబిలిటీ ఉంది కాబట్టి ఇది కూడా డిస్కార్డ్ అని చెప్పండి.
ఇది కూడా డిస్కార్డ్, దిస్ ఆల్సో డిస్కార్డెడ్. ఏ ఈక్వల్స్ టు 0 కేసులో ఇది కూడా డిస్కార్డెడ్. బట్ థింగ్ ఏంటంటే యాక్చువల్గా ఇక్కడ నేను ఏమంటున్నా అంటే ఈ వచ్చే డిటర్మినెంట్ ఏ కూడా రావచ్చు ఇక్కడ, అర్థమవుతుందా సార్? ఈ వచ్చే డిటర్మినెంట్ యూనిక్ డిటర్మినెంట్ వస్తుంది, ఎందుకంటే డెట్ ఈజ్ ఏ ఫంక్షన్ కాబట్టి మీరు ఏ మ్యాట్రిక్స్ ఇచ్చినా ఒకటే ఇమేజ్ వస్తుంది. ఈ ఇమేజ్ ఏ ఈక్వల్స్ టు 1 2 3 కూడా రావచ్చు కదా అంటున్నాను సార్. అట్లా కూడా పాసిబిలిటీ ఉంటుంది కదా అంటున్నాను, యూనిక్ నెంబర్ కదా. సో దీంతో మాత్రం no conclusion. What is answer? No conclusion. So this is a problem, right? What you do is that in this case simply you given determine z అనుకోండి, you check whether z bar is equals to z or z bar equals to minus z ఇలా check చేయండి. Simple, we can get the answer. That is what actually strategy, right? So next problem, ఇది కూడా ఇంత జామ్ లో వచ్చింది. 103 115 114 113 108 108 106 104 113 116 113 116 104, right? 104 108 106 5 114 and 1103. All right, option A is -1, option B 2, option C 0, option 4 4.
Homework sir. వాట్సాప్ గ్రూప్ లో పెట్టండి ఆన్సర్.
సార్ log 3 plus log x log z plus log 3 log y, sorry, log z plus log 3. Yeah, now do row operation. Your log x is there. What you do is subtract, log x log y log z. What you do is that r2 minus r1, replace second row by second row minus first row. Therefore this is nothing but log x cancel, log 2 log z means log 2. Again what you do is that applying the same row operation, r3 minus r1 log 3 log 3 log 3. Therefore these two rows are proportional, therefore it is 0, right? Is it clear? Okay, next is this question asked in JAM. If xi ai bi ci is a number, actually I equals to 1 2 3, are 3-digit numbers. 3-digit numbers. Right, 3-digit positive numbers. In fact, we take positive numbers. 3 digits. Positive integers such that each xi is multiple of 19, then det of a1, a2, a3, b1, b2, b3, c1, c2, c3. Option 1 is divisible by 19. Option B, divisible by, not divisible by 19. Option D is divisible by 17. Option D, none. Tell me, 3-digit positive integers. What is my x1? X1 is a 3-digit number. X2 is a 3-digit number. Right? What is my x1? 3-digit positive integer. What is x2? 3-digit positive integer. What is x3? 3-digit positive integer. Right? And each xi is a multiple of, x1 is a multiple of 19. What does I mean by this? What do I mean by this? Xi divides 19. Therefore, by division algorithm, 19 is equals to some xi into integer for some suitable integer. Right? Each xi. This is true for every xi because each xi is a multiple of integer. Right? Now, what you do is that actually the argument actually second class argument. See the actual number, 3-digit number, we can write in the expanded form. So this is 100. This is 100 place. This is 10th place. This is first place. So 100 into a1, right? 10 into b1, 1 into c1. This is 100 into b1, a1, a2, 10 into b2, 1 into c2. This is 100 into a3, 10 into b3. This is 1 into c3. These are nothing but x1, 2, x1, x2, x3, x4, x1, x2, x3. Now what you do, what you are given? a1, a2, a3, b1, b2, b3, c1, c2, c3. Yeah. Now what you do? See, actually ఇక్కడ ఏం కావాలండి? C1 as it is ఉంది చూడండి. B1 దగ్గర 10 వచ్చింది. A1 దగ్గర 10, 100 వచ్చింది. Now what you do is R3 plus 10 into R2, 100 into R1. What you are getting? A1, A2, A3. This is B1, B2, B3. C1 plus 10 into B1 plus 100 into A1, C2 plus 10 into B2, 100 into A2. Next, C3, 10 into B3, 100 into C3. This is my determinant. But this is exactly A1, A2, A3, B1, B2, B3. What is this one? Anybody? What is this one? Expanded form. X1. This is X1. This is X2. This is X3. Right? Therefore, A1, A2, A3, B1, B2, B3. But what is X1? X1 is a multiple of 19. Therefore, X1 is nothing but 1. Right, ఇక్కడ mistake రాశాను. You need to write divisible, not multiple. What you do is, it is multiple, not multiple, it is divisible. Mistake. Yeah, ఇక్కడ divisible రాశాను, ఇక్కడ multiple రాశాను. This is multiple, divisible. ఇక్కడ కూడా change this, change it, divisible, right? Therefore each exercise should be in a form of 19 k, right? Therefore this can be rewritten as 19 k1, 19 k2, 19 k3, right? Now what you do is applying the property, your row in which 19 is common, pulled outside is a1, a2, a3, b1, b2, b3, k1, k2, k3. Now what you are getting, this is all are integers, a1, a2, a3, it is a 3-digit integer, so it is an integer, therefore all are integer. You're going to get this an integer, therefore this you're going to get 19 into m. Therefore what you observe, this determinant is a 19 into m. That means what you observe, it is divisible by 19. It is divisible by 19, right? So what is the trick behind this? You need to expand the number in expanded form. 100 into a1, 10 into b1, that plus c1, because your options are, it is divisible, it is not divisible, it is looking like this. Then what you do is you need to write the numbers in form of expanded form. So that is a trick, right? Next is example. So x and y are positive real numbers. 1 log y to the base x, log z to the base x, right? Next, x to the base y, 1 log z to the base y. Next, log x to the base y, sorry, x to the base z. This is log y to the base z, 1. Now tell me, what is the answer? Anybody? See, check చేయండి, x1 y1 z1 పెట్టండి, ఏమైంది?
one base 1 0.
Yeah.
Identity matrix.
What are you getting? See, a power 0 is 1 whenever a not equals to 0, right? Log 1 to the base a is 0, right? Once you substitute y equals to 1, this seems to be 0, this also seems to be 0, therefore you need to calculate, this is 0. Yes or no? What you're going to get? What you're going to get, anybody? 0, 0, 0,
వెంకన్న పెట్టాడు ఆన్సర్ 1 అని.
1, 0, 0, 1. Who said?
వెంకన్న.
Okay, good. ఈ ప్రాబ్లం చేయండి, exercise, it's an exercise. So this is also important model. Suppose you're given a question like this, del r is equals to r minus 1, write n 6 r minus 1 whole square, 2n square, 4n minus 2 r minus 1 whole cube, 3n cube, 3n square minus n. Then what is the sum of the determinants? Option A 1, option B 0, option C minus 1, option D 4, right? You need to do it. It is also exercise. Is any positive real number, positive integer, del t is equals to 2t minus 1, m square minus 1, cos square m square, and mct means binomial coefficient FCT 2 power m cos square m. Next is 1 m plus 1. This is m plus 1. This is cos m square. So then this t equals to 0 to m del t is equals to option A 0, option B 1, option C 2, option D 4. Right? Next problem. Itself exercise. Do it in a home. 1 square, 2 square, 3 square, 4 square, 2 square, 3 square, 4 square, 5 square, 3 square, 4 square, 5 square, 6 square. Next 4 square, 5 square, 6 square, 7 square. Right? Option A -1, option B 0, option C 4, option D 2. Right? Did in home. Right? Next, if p lambda power 4, p is it's a polynomial in lambda into lambda square plus s into lambda plus t equals to lambda square plus 3 lambda, lambda minus 1, lambda plus 3, lambda square plus 1, 2 minus lambda, lambda minus 3, lambda square minus 3, lambda square plus 4, 3 lambda. Then if it is true for all lambda, then option A. See, then what is P? What is this T? Right? It is also important problem. Yeah. So with this, I conclude the lecture.
Okay.